Good morning, everyone, and welcome to our first online video where we kind of back up a little bit and look at Carol J. Robot inheritance structure. It's kind of a fake little structure that I made up, and I know that we didn't really have a whole lot of time to go through some of the fun things we could have done with the Carol J. Robot GUI and set of classes there, but this example is a good one for understanding inheritance and polymorphism. So I thought it would be a good exercise for you to try on your own first and then use this video to check. One thing that you should know is that a robot actually inherits from a UR robot, and therefore a robot would have a built-in move method, which is a little deceiving because it's not on the inheritance structure. So I want you to understand that all robots can move, otherwise they wouldn't be robots. So what we're going to do is we're first going to see if for each of the exercises here, if the declaration is okay, and then if the method call is okay. And try and just understand what you can and can't do with references and objects that they're pointing at and what method calls you can make. So in number 1, I've got a robot R reference pointing at a robot object. Okay, so let's look at what a robot can do. Okay, on the left side, its role is a robot. So the only thing a robot can do is move. And so I can have a robot pointing at a robot object, that's all good, but since robots only move, this call right here is invalid because robots can't talk. Okay, so the only capability of a robot is to move, and since you are asking it to talk, that is invalid. So we're done with number 1. We are moving on to number 2. In number 2, oh, by the way, let's take a look at the inheritance structure. The inheritance structure starts with robot, which is really the second superclass. The first one would be UR robot. And then from a robot comes an animal bot. An animal bot is an abstract class, and we know that because it has an abstract method called talk. Okay? Any class that inherits from an animal bot must have a talk method. And you'll see in this example that the two classes, a dog bot has a talk method and a cat bot has a talk method. So those are valid. You cannot instantiate an animal bot and tell it to talk because the talk method is abstract. It doesn't have any meaning until a subclass actually defines and overrides that talk method. So in number 2, I've got a dog bot. It's pointing at a dog bot. So our declaration and instantiation are okay. And can dog bots talk? Yes, this is okay as well. So that's a good, solid yes for number 2. Let's move on to number 3. So now I've got an animal bot R. So if I look at the left side, the role of R is an animal bot. What can animal bots do? Well, animal bots can talk and they can move. Those are the only 2 things that they can do. This animal bot is pointing at a dog bot. A dog bot can move. That's overriding the move of a robot. It can talk, run, and dig. So my instantiation is fine. I've got something general pointing at something more specific, which is fine. But the capabilities or the role, the contract, is for an animal bot. And animal bots can talk. And so number 3, this dog bot is good. It's polymorphic because we are overriding talk and we're overriding move. So this one I'm going to circle because it's polymorphic for overriding of the talk and the move method. It's actually called true polymorphism because of the overriding of those two methods. And what happens there is because of the override, the decision of which method to actually call occurs at runtime. And a set of summary notes online will give you a further explanation on that if you check on Blackboard under Documents and Presentations. Let's move on to number 4. I've got something general, an animal bot, pointing at something more specific, a cat bot. All of that's okay. But let's look at the role of the object. The role of the object R is an animal bot. The only thing an animal bot can do is move or talk, and therefore, move or talk, and therefore it cannot run. So that method there is a no-go because it only has the capability of an animal bot, and animal bots can't run. So animal bots don't run. Perfect. Moving on to number 5. I've got something general pointing at something at the same level. So the issue there is that you can't instantiate an animal bot. And the reason why is because it's not fully defined. The talk method is abstract. So this instantiation is invalid. Can't instantiate an abstract class. Because there is no talk method that has actually been defined. Only the subclasses would have the definition of what it means to talk. All right, let's move on to number 6. Number 6, I have a cat bot pointing at a cat bot. Those are always easy because that declaration is good to go. And in number 6, R is told, the cat bot is told to scratch. You'll notice that scratch is part of a cat bot method. And so this is good as well. So the question is this polymorphic? Well, it's not a polymorphic call because I'm not overriding, I'm not telling the cat bot to move or to talk. And those are the two overriding methods, and therefore this is not polymorphic. No poly. But everything's valid. Cool. Let's move on to number 7. I've got a robot R pointing at something more specific. So I'm going to switch colors here. Let's go to red because it's getting a little hard to see. It's okay to have that instantiation. Keep in mind that the only thing a robot can do is move. And so this is okay too. How will this robot move? So this is going to be polymorphic. And the reason it's polymorphic is even though it's a robot and a robot can move, the way it moves is as a dog bot. So moves as a dog bot. Should actually capitalize that. It moves as a dog bot. So it's going to follow the move code that's up here under a dog bot instead of the move code for a robot. And that's how polymorphism works. And it will make that decision at runtime based on the type of object that it is. All right, We're on to number 8. The last one, yay. All right, robot R is a new dog bot. This is an OK instantiation. I've got something general pointing at something more specific. The role of this is to, the role of a robot is to move or to talk. All right. Can robots talk? No, robots cannot talk. Wait, did I just screw that up? I did. Robots cannot talk. So there you have it. Robots can't talk. I said that they could, but they really can't. So this is a big old X right here. And there you have it. Our 2 instantiations that are legal and exhibit polymorphism then are numbers 3 and 7. Great. And finally, if you take a look at number 4, and you wanted, let me scroll up to number 4. If you had an animal bot R as a new cat bot and you wanted this to actually run, what you could do is you could typecast. Because you know it's really pointing at a cat bot, and you know that cat bots can run, so you can get a legal call by saying, I've got a cat bot. I know that this guy is really a cat bot. And again, I apologize that the writing's so terrible. And you would typecast R as a cat bot, and then after you do that, you could say, hey, what I want you to do is run. And that would be a legal call. Hopefully that was enough to get you understanding how this polymorphism thing is working, and I hope to come back to you tomorrow with another video. Hope you have a great day. Bye-bye.